Hey, it worked. Running Linux, you never know. All right, I'm Greg. Like you said, I do stable releases. Linus does the development releases. I'll talk a little bit more about that. As you all know, Git came from Linux. It was our development model that spawned this crazy beast. We're sorry, but it works really, really well. So I'm going to talk about what we do and how we use Git, because it's a little bit different than most other groups. First, feel free to heckle, ask questions, interrupt. Makes this fun, or you can wait till the end, but interactive is good. So let's talk about it. So this is the size of the kernel today, as of a couple weeks ago. That was a 4.5 release. Release numbers are just numbers. They just increment forward. They don't mean anything. That's all. So 4.5. Like you see, 21 million lines of code. It's a lot of code. All the drivers for Linux kernel are in the source tree. This is different than any other operating system had done before. Most of them kept them separate. We put everything in the tree, and that makes it better because we can change APIs, we can change the way things work. We can see how multiple drivers work for sort of the same hardware, merge them together. On average, a driver for the Linux kernel is about 1/3 the size of other operating systems. So it works out really well. But still, we have a huge, huge tree. But you don't run it all. My laptop runs, 1.6 million, I think. Your phone runs about 4 million, no, 3 million lines of code. It's different than what I do, but there's 5% of the core of all those 2 million lines, 21 million lines is the core of the kernel. Everybody runs that. The rest is all other stuff. So here's what we did last year. 4,000 developers, at least 387 companies. I say at least because I keep track of this and I haven't been doing that for the past year. So if you submit a patch to the kernel and it's not obvious who you work for, I'll send you an automatic email. Again, I haven't been doing that. It should be about 450 companies, we think. We cracked 400 different companies about 3 years ago. We cracked 3,000 developers 4 years ago. 4,000 developers we're looking at this year. Largest software project ever. It's very, very huge. It's also a pretty fast rate of change, kind of. So this is what we do. Doesn't seem that bad until you realize the scale. This is what runs the world. The Linux Foundation told me to stop using the word scary in this presentation. I'll use it a lot. This is a lot. This is supposedly a stable kernel that runs the world's it runs everything, runs the internet, runs your laptops, well, a few of your laptops, runs all your phones, runs lots and lots of things, runs Wall Street, runs your air traffic control, things like that. Scary stuff. Sorry, I won't say scary. Not only this is the number you should be scared of. That's a lot. We keep going faster. Every year we go faster. We think we're plateauing. Every year I do this presentation, I say, we can't possibly go any faster, and every year we do. 10 years ago, we were going 2.5 changes an hour, and that everybody thought was unsustainable. There's no way we can keep up with that. 5 years ago, we were going 5 changes an hour. Everybody's like, no, we can't go faster than that. We're going faster. Every single year, every single release, we're kind of plateauing, but we still keep going up and up and up. And the interesting thing is these changes aren't just in drivers, they're across the whole tree. So out of all those lines of code, like I said, the core of the kernel was 5%. 5% of these changes are in the core kernel. Drivers are about 40%. 40% of the changes are in drivers. Networking is about 10%. 10% of these changes are in the networking stack. It cuts across the whole tree. This goes against every previously thought software methodology of how to make a stable system. But we created something nobody else had. So maybe you had to break those rules. Again, scary. We went even faster. 4.3 release, 2 releases ago. We're up to 8 changes an hour. We did break 9 changes an hour last year for one release. I think the release we're about to do in a couple weeks, we're going to be about 9, maybe 10 changes an hour. We'll have the largest size of a release. Again, we're going faster and faster and faster. What this means is, if you were comfortable with what we did a year ago, for the past work we did, and your driver and your tree is not merged into the main kernel, we are going faster, so you have to do more work to keep up with us. And that's something a lot of companies don't realize. If they try and fork and go off on their own, that's great, it works for a while, but again, we are going faster and faster and faster, and they can't keep up. They have to invest more money and more time. The best thing to do is merge into the kernel, and away you go. It costs you money to keep your code outside the kernel. So how do we do this? Two big things: time-based releases and incremental changes. Time-based releases. We started this about 10 years ago. We said, let's stop doing this stable, unstable development cycle, and let's just do a new release. Everything's going to be stable. And we said, let's make it between 2 and 3 months, and we are. We're about 6 to 7 weeks. We do a new release. And this is good. This means that if you are developing a new feature and you try and get it merged and it gets rejected, well, then you have another release in 2 months. 3 months, you can get it merged in there. You don't have the back pressure of, oh no, we're not going to get in this release because we're doing a release every 6 months, every year. We have to accept it now. We can push it off, get the best technical thing working, and get it merged next. It takes away that barrier of us having to accept stuff that we don't want to. It also is very reproducible. We know when a new release is going to come out. Companies can figure out, I want to base my phone, I want to release it on this date, so I'm going to pick this kernel, that's why I need to get stuff merged in, and it works out really well. We are very, very regular. Linus keeps wanting to go faster. He's knocked it down to 6 weeks a couple times. He says he wants to do 5 weeks. I don't know. That might be tough. So how do we do this? So here we go. Numbers. All right, so Linus releases 4.2.0 at the top. And then I'll talk a little bit more about this later, but all developers throw a bunch of stuff at him for 2 weeks, and he does release candidate 1. Increments the number, 4.3.0, release candidate 1. And then every single week, we do another release candidate. After that first release candidate, it's bug fixes only, or regressions. We are very, very serious about regressions. Because we move so fast, and because we move so quickly, we want people to be confident about upgrading. You should always feel comfortable about upgrading your kernel. It should just work. If it doesn't, we did something wrong. We made this statement a decade ago, saying we will not break user space, and we've held to it. Facebook has talked about how they update their internal servers every single release. They haven't had a problem in about 3 years. It works really, really well. So, bug fixes only, bug fixes, or regressions. We will revert things using Git. I'll talk a little bit more about how we use Git later. And then up to RC6, RC7, everything's settling down. He does a new release, and off we go. That's how we do it. So we started doing this for a few years, and we realized, wait, what happens if there was a big nasty bug in 4.2? What do we do? So we came up with the idea of stable kernels. So what I do, I'm in charge of these. I fork from Linus, and I do 4.2.1, .2, .3, .4. Every about week, I do a new stable kernel. And the rule for stable kernels is it has to be in Linus's tree first. And that's really, really important. We never want to diverge. We never want to take something in the stable kernel that isn't already in Linus's tree. And conversely, I don't want to take stuff that's been modified. Sometimes people will say, well, it was a little bit hairy on how we did this in Linus's tree, so I'll give you a simpler patch. No, I want the identical patch. Because 95% of the time, if I take something that's been rewritten a little bit, it's buggy because it hasn't been tested. And it always happens. So we have some rules on what can go into a stable kernel. Bug fixes only. Has to be about 100 lines, has to be obvious, which is in the eye of the beholder, of course. Or it can just new device IDs, like just add a new device ID for your USB driver or device or something. Has to be like that. There has been some bigger changes going in. Sometimes when the memory management guys said, here's this series of 20 patches that are all 100 lines, but they all fix something. I'll take that. But again, you keep on going, and then the more powerful thing is I get to throw this away, and you upgrade to the next one. There's a little bit of overlap of a few weeks, but we throw it away and on you go. So all the distros that you run that are community-based, like Fedora, OpenSUSE, Arch, Gentoo, they all run off these stable kernels. The enterprise people pick these kernels and go for a longer period of time. They like a long-term kernel. And I used to work for Novell in SUSE at the time, and I was in charge of our kernel team. And I realized that I could use these kernels as my day job, because we were maintaining a kernel for a couple years. So let's do that. So we have something called a long-term kernel now. I pick one kernel tree a year, and I maintain it for 2 years. Right now, 3.14, 4.0, and 4.4. We moved from 3 to 4 just because the numbers got big, and you think the difference between 3.17 and 21 is less than it is between 7 and 10, and it gets, or 11. Mental. So normally I pick one a year. 4.4 was odd, and at the kernel summit, we decided to do something different, and I picked one at the beginning of the year. So that one was a surprise. But this way, it actually lined up good. The new Chromebooks that are coming out will be 4.4 based. New Android will be 4.4 based. I go around and talk to companies, see what they're using. I think Debian's gonna be 4.4. Maybe? Canonical? I don't know. Somebody else is gonna be 4.4. So I maintain these for 2 years, and then I drop them. This works well for a lot of companies. Bigger companies like, again, SUSE, Red Hat, Canonical maintain them on their own a little bit longer. In Japan right now, they are replacing they call it social infrastructure. I think they need a better name because I think of Twitter when I think of that. It's their streetlights and their railway systems. And all that's converting over to Linux. And so a lot of companies there have come to me and said, we need you to maintain a kernel for 20 to 30 years. And I said, yes, retirement. So they're gonna have an interesting problem. They're gonna pick probably the next long-term stable kernel I do next year, and they want it for 20 years. And that's an interesting thing. How are we gonna support that, and what are we gonna do? So I'm working with a number of companies there, so the Linux Foundation, and we're gonna try and figure out how we're gonna maintain a kernel for 20 years. That's gonna be interesting. Think about what Linux looked like 20 years ago. It was pretty bad. The interesting thing is gonna have hardware that runs for 20 years, so I might end up with a big light, a stoplight in my living room or something, I don't know. So long-term kernels. Questions? This is how we do releases. You guys are easy. Oh, come on. All right, now let's talk about Git. So, developers. We have almost 4,000 of them. And they make a patch, they make a change. And every change that goes into the Linux kernel has to be standalone. It has to not break everything, and it has to be, quote, correct. We cannot break the build. All those lines of code, all those changes that go into the kernel, none of them break the build. Oh, another thing I forgot to mention. Those are the patches that are accepted, not that are submitted. On average, I accept about 1/3 to on a good day, 1/2 of patches that are sent to me. So there's a lot of work going on out there. It takes you a number of times to get changes in, and a lot of stuff gets rejected. So there's a lot more work than just what you see accepted. Just to give you a sense of how big our sense of scale is. Okay, developers. When they make a change, has to be obvious, has to be broken down into one thing. We require people, if you're gonna do a complicated thing, to show your work, like your old math professor said. You break your stuff down into individual steps along the way. Every change is correct, every change doesn't break something, and you have to show a long series. This puts more burden of work on the developer, but that's what we have a lot of. So we waste developers' time. Because we don't have many maintainers, we don't have many reviewers. That's our most precious thing. You need to send me a set of patches that look obviously correct. I'd be stupid not to accept them because they're just so easy and simple, and you broke it down and showed all your work. It's hard to do that. It's a hard development process for people to learn how to do, but that's what we make developers do. So they make a change, and then they send that through email, to the owner of the file or the driver. And we have about, how many do I count? We have 1,000 maintainers these days, which is crazy if we have 4,000 developers. But I looked at that list, and there's a lot of people on the list of maintainers that haven't done a lot of work in a long time, so they don't show up on the list of developers. So I think we have about 700 active maintainers. So they make a change, and they send it off through email. We have mailing lists for every different subsystem of the kernel, like USB, there's a USB mailing list, SCSI, just SCSI, block, memory management. There's the big Linux kernel mailing list, which gets about 400 to 500 emails a day. The big secret is nobody reads that. We all filter. Andrew Morden, I think, reads it all, but he's different. I'll show you some more work that Andrew does later. So they make a change and we review it. We look at it in email, we respond back in inline comments, we don't top post, we don't post in HTML, it's all plain text. And that's good. It's good because we want people who might not have English as their first language. We want people from other backgrounds. Through email, you're anonymous in a way. It's just what you're writing. It's just the text right there. Some projects, and I will point at OpenStack, they make people get together in a room or they make people work on IRC together, and I don't think that works well. I want it so that if I respond to an email, they can take a day, they can run it through Google Translate, they can think about it, and then they can respond back. Because that works better. That works better for people who, again, English is not their first language. We want to be much, much more inclusionary. We don't know race, we don't know nationality, we don't know anything, and we don't keep track of that. And that's good. So again, email, plain text, old school, works really, really well. So yeah, they look at it, they say yes, no, whatever, and they go on. So here's a change. You guys all know what patches look like. Here's a really old one. We make people include a few interesting things. First line, again, good Git history. I mean, we created the Git style, so I guess you can look at that. One line, changelog text saying what it did, and then we say signed off by. Every person who creates a patch has to say signed off by. We don't require contribution copyright assignments, we don't require CLAs, you own the copyright, you just have to say signed off. And I'll talk about that in a minute. And then the owner of that subsystem at the time was David, of the USB gadget. He said, yes, I acknowledge, that looks good, an email. And then I picked it up at the time and I said, great, I sign off and I add it to my tree. Again, the line was an obvious, let's actually look at this variable before we dereference it. Isn't C wonderful? That's it. That's a patch. Obviously correct, and away it goes. So let's talk about signed off by. The Git developers know this because they require this as well. Linux came up with a developer DCO, Developer Certificate of Origin. It's a little bit more complex, but this is what it means. It means that you're allowed to contribute this change to this project under the license that the project has. A lot of other groups have picked this up. etcd from CoreOS are using it, Samba's using it, Docker's using it. A lot of other groups are using it. I really recommend it. It's a very solid body of legal work. It's again, this isn't the legal terms, but it's very readable. It's something really, really good that Linus did. It's like the exact opposite of a CLA. It's giving permission, not requiring all these other things. Works really, really well. The Git guys, the Git developers use it, works out good. So everybody says signed off by. So what this means is, if you go back and look at this patch, not only is it signed off by, so there's a legal term there, it's now a path of blame. So if this is wrong, I get to go, hey, somebody says, hey, Greg, David, Robert, fix it. And your name's on it. It isn't a company's name. You aren't hiding behind an alias. It is your name on the patch. And when your name is on something that's public, you do better work. You just do. That's a really, really powerful social experiment that's made the Linux code base really good. But it also means it's the best audited body of work. I can take any one of those 21 million lines of code and say, using git blame, who changed this line and who reviewed it? 2 people, every single line of the 21 million lines of code. I've given talks to companies about this. They can't even claim that for their internal code bases. So not only is it the largest software-driven, community-driven software project as far as size, it's also the best audited body. There's no question where everything came from, which is pretty amazing. So, path of blame, it's fun. So, then the developer sends it to a subsystem maintainer. So subsystems are like USB, PCI, networking, wireless, and now we all have Git trees. There's a bunch of Git trees. We use git.kernel.org. We don't really use GitHub. I think we have about 200 different trees publicly. A few people use GitHub, but most everybody uses git.kernel.org. So these trees are now public. So we have different branches. We have one branch that's going to go to Linus now for bug fixes, one branch that's going to go in the next release. And then we put the patches in there, and that's public. That's an immutable branch. We don't rebase, never rebase. And it's public now. So then what we do is every single day, Stephen Rothwell in Australia takes all those subtrees and he merges them together. And then he builds them on about 20, 30 different architectures, no, maybe more now. And he boots them. I think he boots 30 different ones and tests it. So then I'll get an automatic response every night if something, like if my tree messed with the networking tree, or my branch over here messed with this other subsystem branch, and it boots. So Linux Next happens every single weekday. It's really good if you want to see what the next version of Linux is going to be, use Linux Next. If you want to do development off Next, not off what Linus has, because what Linus has is old. This is what happens. So every single day all our trees get merged, yeah?
Is the first time that a compile test is done at the next level?
First time a compile test done at next level. Hopefully this person did a compile test. And then that person, and then that person. Usually I have gotten a lot of patches that this person never did a compile test. So it's up to the subsystem maintainer to at least build it. But there's something else happens, I'll get back to that. Linux Next just tests the merge and tests that the merge works. Because even though I'm a maintainer of USB, in the kernel you don't own anything absolutely. The networking people can say, hey, we got networking drivers that mess with USB stack, we need to change this over here. And then great, it goes to the networking stack, sometimes I'll see it, sometimes I won't. Other people can change your code. Yes, you're a maintainer, yes, your name is on it, but other people can change it as well. It isn't absolute. So that works out great. So then, and Andrew Morton's over on the side picking up things that aren't maintained. We have a number of subsystems where people don't maintain them anymore. Or like those 1,000 emails, some people don't respond to their email anymore. Some people pass away, you know? We're all human, people die, people move on. So he's picking up all the random pieces and he has a tree out there. Andrew doesn't use Git, he uses Quilt. And Quilt is a stacked bunch of patches on top of a base. Works out really nicely. And I use Quilt also for the stable kernels. Git doesn't really work well with that, because he can rebase his tree and do fun things like that. So that's what happens. So this was working really well until a couple years ago. We realized nobody was testing anything. It's really hard to write a test for an operating system. If you say, hey, it booted, that works, which is a non-trivial thing, to be sure. But it'd be nice if other people tested. It'd be nice if we didn't break something on one of those different architectures. We support like 50 or 80 different architectures. It'd be nice if we didn't. So Intel came along, and some developers at Intel did a skunkworks project, and I think they just grabbed a whole bunch of CPUs that nobody was using. We don't know what they're using. And they created something called the zero-day bot. And the zero-day bot scans all our trees, all our public trees, and they build them. They build them on, I don't know, 50 different architectures, different random configurations, different other things, and they run tests. They run static analysis tests. We have a bunch of static analysis tools. Kernel, which is a really good tool for testing out, finding patterns in C code and seeing what's wrong. We have a ton of those. We have other static analysis tools. We have something called Sparse, Linus wrote, and a number of other ones. They all run through this thing. He also is now picking up patches off mailing lists. You post a patch to a mailing list, you'll get a response saying this broke something, which is great. I don't know how he does it. I don't know what's really behind it. I talked to him last year, and he said he could handle 7,000 more Git trees. I think it's a testing ground for Intel's new processors. I don't know what he does. We're happy. But so it tests everything. It tests every single commit of your commits you push. One day I landed on it after taking a flight. I pushed a bunch of work out. I went to get a coffee. 15 minutes later, I got an email saying this patch in the middle of all these commits broke the build, and here's an automatic patch that fixes it. So now we have scripts that are writing patches. Who owns that? That's another interesting thing the lawyers are going to deal with. Anyway, so zero-day bot. He tests a bunch of things, and that's where we're doing testing. We're doing a bunch of testing. The performance guys are doing testing in there to make sure that we don't slowly degrade or different things as we add new features. That's where the testing happens. Every single day, really, really fast. It's amazing the processing behind that. That happens. So then, when I said we had a merge window happens, all the subsystem maintainers throw their stuff to Linus. The rule is it had to be in Linux Next first. We used to be really bad about that. Now we're getting better. I think about 95% of the patches that end up in Linus's tree were in Linux next. Other 5% sometimes come in during the merge window. And there's like 2 to 3 that we don't know where they came from. That's not good. We're getting better. But I tell Linus pull from this branch. Linus does not pull from next on his own. And that's important. That's important because sometimes my tree can be broken. So I maintain the TTY and serial drivers as well. One release, we had something wrong. It just wasn't working. All these changes, it wasn't working well. We couldn't figure it out. So I said, I'll just wait. I'll hold off on the big merge to Linus. I'll send a few bug fixes. Let's wait till the next release. Again, 2.5 months, it's not a big deal. So he couldn't, if he had pulled my tree, it would have broke. It would have broke for a lot of people. So we throw things to him, and then he merges. So in a merge window, he's taking about 10 to 11,000 patches in 2 weeks. Git is nice. It's all done through Git pulls, except for Andrew Morton. Andrew sends some email series, and he applies them. Again, Git applies mailboxes of emails very, very easily, thanks to, because it was our development process. It works really well, but that's all Git. Everything blue on up is Git, and it works really fast, really easy. Yeah, and then he does a new release, and off he goes. So, questions? Oh, come on. Yes. So the question is, do we, because we have to break everything down in individual patches, a refactor, and a fix, that's really rare. That usually is very rare. Normally it's like, if I'm going to refactor something, it's usually the next patch that does something real. And even then, that's very rare. But again, if we take 10,000 patches and 5 of them were refactor, okay, it's fine. We'll take it. But if you're doing that, again, that's a step along the way. You have to show your work, and that's fine if you want to refactor things. We do like to see, if you're going to do a long series, that you're fixing some bugs, the bugs first. Fix the bugs first, that way we can backport them to a stable tree easier. We don't want to have to deal with the refactoring, because then that can get messier. But yeah, it's actually pretty rare.
What happens if you and Linus are on vacation, or you're on vacation, or Andrew Morton's on vacation, so if the human element breaks down?
Good segue. What happens in the human element if we break down? So this looks like a nice, pretty tree, right? Triangle. I graphed this one year. It turned out to be 1 meter by 10, 15 meters long. It's a mess. It's a network of connected people. It doesn't look this pretty. We can route around anybody. The good thing about Git and the way our patch process works is if I go on vacation, I just get routed around, and it works fine. Somebody comes in through somebody else. Like, again, networking, David will say, hey, I'll pick up USB patches for a week. No problem. It goes in through him. It works really, really well. Everybody just gets routed around, and it works really good. Well, another thing about this is, because we're using email in the beginning, we all review everything. But as we move up the stack, we start using Git, and I can't see those patches. So what we have here, really, the kernel development is not so much it's a tree of development that we're reviewing everybody's stuff, but it's a tree of trust. So I trust people that I take a pull request from. I don't always trust that they got it right. I trust that they'll be there to fix it if they got it wrong. And that happens a lot. Like, there's some people I'll just blindly say, great, Alan, I'll take your patches, no problem. And because I know he'll be there when to fix it when it's wrong. And that's the important thing. If I'm taking patches from people and I put my signed off by, I'm on the path of blame. I am now responsible. So I have enough work. I want to take patches from people that I know will be responsible to fix them. So if you're trying to get into kernel development, it's hard because we have to trust you. We had a problem with a networking stack about 5, 6 years ago. A huge, nasty, hairy change landed. Finally, it was big and complex. The day after it was merged, the email address disappeared. It took them 6 months to unwind the mess. The networking developers are very paranoid now. You have to have shown a history of good commits and good changes and good support and being there and asking questions to prove that you'll take your patches. Sometimes I'll just ask a dumb question back to make sure that the person is even listening. Like, hey, why'd you do it this way? Or things like that, to make sure that there is going to be some feedback. You are going to become part of this community. I'm not going to be responsible for maintaining this code for forever. Because we do. I maintain code that I wrote almost 20 years ago. Other people do that too. It's nasty code. But we all work through it and do it. But again, we have a web of trust. So I trust 5 to 6 people. Linus trusts 10 people. It's, again, a tree of trust. And that's how it works. So the kernel development process, because we put our name on things and because we take pull requests from other people, it's really a development model of human interaction. We're trusting people. We're trusting people that will do the right thing, that you'll be there to fix things. And that's what the kernel development process is. It's not just pure technology. It's not just pure blind patches flying around. It's people that know each other. We travel around, we meet each other once a year. We have subgroup meetups once a year for different subsystems. We meet and work with other people and other developers. And that's good. One of my best friends now lives in Germany. 15 years ago, he didn't know English. It's a really weird development model, but it's human interactions. And through human interactions and human responsibility for their changes, we created something that really works really, really well. Something no company could have ever created. And that's Linux. So, questions? Yes, no.
So earlier you said that it was great that you use email for everything because you're democratizing contributions and you don't care about people's background. But now you're saying at the maintainer level you actually do care about people's backgrounds. Are you worried that this is...
I don't care about your background. I care you're going to be there. So I have to rely on you. Because if I take code from you for fixes, for one drive-by patches, so half of those patches that we take, half those patches come from a person that is never seen again. That's easy. That's fine. One drive-by spelling fix, new device ID, simple bug fix, great. I don't care. If you're adding new features, if you're adding a new subsystem, yes, I want to make sure you're going to be around. I don't care who you are. I just want to make sure you're going to be there. Funny story. Many years ago, we started having the Linux kernel, or we were worried about Microsoft sending us things and we were all being paranoid. Somebody showed up out of nowhere with these beautiful patches for the plug-and-play subsystem. We had no idea how that came about, where they came from. So I made him prove, I think it was a him because it said Adam, made him prove where he got the information. He pointed out the public knowledge, pointed out where it was. A couple years went by. We have a big kernel developer meeting every year. He got invited. It was in Canada. He showed up with his mother because he was in high school. We had no idea. He now is a professor at Stanford, a really brilliant guy. But again, we had no idea that he was a high school student. And it didn't matter because he was a maintainer of that, but he proved the back and forth of where he got that information from, where it worked out, and it went on from there. So, yes and no.
How do you deal with the conflicts between the maintainers? Unless they just have to go into place?
How do we deal with the conflicts between maintainers? It usually doesn't happen. Git is good at merges, as you know. The kernel tree is pretty diverse. So USB doesn't touch networking, doesn't touch all these other things. Everything's pretty standalone. It's up to the subsystem maintainer usually if they're going to be having to deal with merge issues. But other than that, we will get, if you look on the Linux Next mailing list, Stephen will send out automatic response saying, hey, this conflicted with this, I don't know what to do, or here's the merge that I did, is this correct? It'll tell us. So I get about one of those twice a week. So it happens, but they're usually minor conflicts. Or API changes, like if somebody changes a new API in like networking and I'm adding a new driver through this other tree, well, I can't break my tree, so I have to be aware of that. And he notifies us. But it's usually pretty minor. For the amount of changes we do, it works out really, really well. It's scary how good Git can handle merges. Yes? I take a bunch of patches from all over the tree. I could be doing cherry pick. I could use cherry pick, put them in a branch. But the problem with my patches is sometimes, and I post them for review, sometimes the 5th patch of a 20 patch set, because they're all individual patches, shouldn't be in there. The maintainer says, no, wait, that broke, or no, you shouldn't do this, or wait, quick, add these other ones after that. I would have to rebase that tree. I don't want to rebase the public tree, ever. So I don't do that. I use Quilt. Quilt lets me put in and remove and reorder and restructure things. And then when I do a release, I do Quilt AM, or Quilt, what was it? Git Quilt mailbox, Git Quilt apply, sorry. It's a commit, or it's a command that only me and a few Debian developers use, based on how bad it works. And it creates a Git tree and applies them and goes away from there. So once we do a release, then it goes into Git. Andrew wrote Quilt. Actually, he wrote something previous to Quilt. So again, he takes a lot of disparate things from all over the place, and he reorders them, and he also doesn't send them all to Linus. Some of them he'll hold on to for 3 or 4 releases. He'll pick up random things, and then he'll sometimes send those random things to the other subsystem maintainers because we missed them. And then when he does that, he'll just drop them from his tree if he sees that they show up in our tree. So he uses Quilt because he can reorder things and it doesn't bother anybody. There are 2 different models. They both work really well. I really recommend people look at the different models if you're curious. Yes, I think last question, over time.
Can you talk a little bit more about the role of the folks who have a more sort of system level interest, like the performance people who might need to influence or have conversations with or edit or even reject input from multiple different subsystems that are normally pretty independent?
So what's the role of performance people who would touch things across subsystems? It doesn't happen. Only thing that would happen performance-wise, think of SCSI or block, the block layer people. They have to worry about certain things. Again, the memory manager guys, I would joke, hey, you're writing a driver for memory. Aren't you guys finished yet? But they keep going at it. Again, we are in pretty siloed things. We all work together, but it works out well. Very rarely do we cross paths. So I'm out of time, and I'll be here today. Thank you very much. Oh, a penguin picture. And again, the talk was online, and that was my obligatory penguin picture.
One more really warm welcome for Greg. So, thank you, sir.
Thank you.